Welcome to LIS754 Systems Analysis and Design, and in this session we are going to talk about entity relationship modeling. We're actually going to spend this session and the next session talking about data. Its importance to systems should be self-evident. It's what drives the software. When we talk about that overall systems model of input, process, and output. Input is the data, right? That's what we're talking about, the input to the system, the thing that makes things work. And what we get out of a system is more data or modified data. And so how we think about data is really central to systems. We've been thinking about what our system is going to do. We've been thinking about how we're going to plan this system, but now we're in the guts of it. We're going to spend quite some time thinking about the data that our system needs. And when we think about data, one of the important things we have to think about is how do we represent this data? And when we say that word data representation, what we're really talking about is what form does that data take? What form does that data take? So let's think about something simple like a name. We can think about data, and one of the important pieces of data we have is the person who we're working with's name. So if we have a student name or a teacher name, or we have a company name, or we have a school name, or we have a library name, or we have an author name. I mean, we can think about a million different ways that we think about names. And so we can't just say name. We have to understand that there's a modifier to that word name, that we have a descriptor to that word name, student name, teacher name. We also have how we're going to format that name. So are we going to do it as one big field where you've got the name Stacy Kowalczyk in a name, or do we want to say the first name is Stacy and the last name is Kowalczyk? The first name is John, the last name is Smith. How are we going to save that in the system? That's what we're talking about with representation, that we have a way that we understand how we're modifying that name in terms of a description and how we are going to actually put it in a system. We want to think about the issue of redundancy. One of the problems that systems have had over the years is that due to the way that they were designed or implemented, that sometimes we had to duplicate data. And when data is duplicated, it is rife with the possibility of errors. If I have a name in the grading system and I have a separate name in the enrollment system, the probability that those names are going to get messed up is high. Addresses, phone numbers, any information that is stored in multiple places within an organization has the probability of getting out of sync. We think about data because there are significant issues in retrieving data. So we can get all this data, how do we find it? This is a problem that libraries have thought about for a very long time because libraries started in the 1960s with computerized data pretty early in having vast quantities of data. So 20, 30 million records to describe the books in a library. And so retrieval of that data, searching and finding and having it identified clearly so that we can find that book or find that data, regardless of what format it is a big deal. And so we worry about identifiers. How do we identify this data? So both, I don't know about you, but I find that having to know my Dominican ID number is somewhat problematic. I never remember that number. And in fact, I was issued two. So I have I started off cycle, I started in January. And so the process got screwed up. So I actually have two identifiers and two records in the system. And I have had the hardest time getting those reconciled. So redundancy and identifiers are super important. And then there's relationships between data. So if we're going to try to reduce redundancy, then we might have to build relationships between data. The reason that data has been redundancy of data is built into systems is because I have a system for the registrar, I have a system for the bursar, we have a system for the grading systems in a school, and so each of those systems has their own data structure. So data, I have my name in all of those systems. If I have one name, then there has to be a way for those other systems, those other processes to find that name, right? If I have one name, then there has to be relationships to those other systems and pointers to those systems. And so we're going to spend some time thinking about how that would work today and how we can model data to reduce redundancy, to improve retrieval, to have clear and useful representations with good identifiers and clearly defined relationships. Most modern systems, that is, systems written since 1985, if you can think of 30 years as being modern in software, have used a database as a storage and retrieval mechanism for their data, a database, most specifically a relational database. That is, there are other types of databases, there are other types of data stores, but most systems use a database, a relational database. And the way that the database, a relational database, is often modeled is using something called an entity relationship paradigm, a process in which we develop a blueprint, a diagram, and a blueprint that clearly describes how the data is managed and stored in the database. This is part of the design process. And we think of this as a collection of entities, a collection of things. Data is almost always a noun. Data describes nouns and a relationship between those entities. So an entity relationship allows us to create a database design. It's a graphical tool that's really great for communicating how this system is laid out, how the data is going to be laid out. It's very widely used. It's a way that identifies objects, these entities, and their relationships. So it's useful in a couple of ways. First, it's really helpful in just laying out the concepts. It's helpful in the design process of the data. If we just start looking at making tables, things get messed up really quickly. It's a good way to conceptualize the data and understand it. It's a documentation and it's a communication structure. It's really useful from the designer's perspective. It's really useful from the database administrator's perspective, from the programmer's perspective. It's really useful within a development team to have an entity relationship diagram. All right, so let's get to it. What are the things that we're talking about when we're talking about an entity relationship? Well, of course, we're going to talk about entities, right? The things. We're going to talk about relationships, right? The relationship between the different things. We're going to talk about something called cardinality. And cardinality refers to the numbers, the nature of the relationships, the numbers of the relationships, and we'll spend quite a bit of time talking about cardinality. And then attributes. So let's talk a little bit before we go on about how we can classify relationships. So we have mandatory relationships and we have optional relationships. So if we have a course in our course management system, we can create a mandatory relationship that every course must have one teacher. It has to have a teacher. We can't have a course without a teacher. And I really hope we never have airline flights without a pilot. Even if things are on autopilot, it's awfully nice to have a person there to make sure that everything goes okay. So a flight must have one pilot. Those are mandatory relationships. There are certainly optional relationships. So in a business, an employee may or may not be assigned to a department, right? A patient may or may not be assigned to a bed. If they're an inpatient, they may not have a bed. Not every teacher must be assigned to a course. So if you're a teacher on sabbatical or you're doing a special project, you may not every teacher in the system would have to be assigned to a course, but every course must have a teacher. And cardinality identifies the numbers of instances of an entity that can be associated with something. So if we have mandatory, then we must have at least one. But if it's optional, we can have 0, and we can have a maximum cardinality. So let's go and talk a little bit about cardinality. We can force cardinality, and we can force that we have a one-to-one relationship. So a manager heads one department and a department has one manager. A course has one teacher, but we don't always have one. So one-to-one doesn't work for everything, right? We have one teacher to a course, but each course must have one teacher, but a teacher may and probably does teach more than one course. The same thing with students. And we can have many-to-many relationships. A teacher teaches many students and a student is taught by many teachers. An employee, and we can have one-to-many, like we were talking about teachers. An employee works in one department and one department has many employees. And we can see how that's pretty straightforward. So we really have 3 cardinality constraints: one-to-one, one-to-many, or many-to-one, either way, or many-to-many. That's it. 3 cardinality constraints. And it makes sense if you think about it. So when we draw this, the diamonds are relationships, the squares are entities. So if I have, this is a relationship of, teacher or course has a teacher, right? A mandatory one is a line with the 2 little lines. Let's make this simpler. I'm going to break this down. This little line here means mandatory. This little 0 here means optional. We have 2 indicators on this line that describes the relationship. Mandatory, mandatory, optional, optional, mandatory 1, mandatory many, optional 1, optional many. So the multiple lines means many. The single line means 1. The first indicator is mandatory, indicates if it's mandatory. Oh gosh, excuse me. If it's mandatory or optional. This is a useful slide to keep around when you're doing entity relationship modeling. I actually need to remember all the time when I'm doing this. So I have this little slide up in my office. So let's think about modeling a school. Each school may enroll many students, or it may not enroll any students at all. It may be over the summer. There may not be any students enrolled in the school. Each student attends exactly one school. We don't have students in multiple schools. One student, one school. And so we can diagram this. Oh my gosh, what happened? So we can model cardinality using a tool like Glyphy or other tools. And here we have our student and our school. So a student has a relationship with the school that is one and only one. So we have the one little line that's for the top line is for mandatory, and the second line is one. This is a mandatory one. But schools can have multiple students, but they need not have any. So there's the optional, there's the little zero that's optional, or the little circle, or O for optional, and then the multiple, the little crow's feet that indicates multiple. And I made this in Glyphy, so Glyphy is a great little tool. If you scroll down that sidebar, the navigation, you'll see that there's something called entity relationships. This is an entity, this is a relationship, and we'll talk about what those are later on. And then here are all the ways that you can have relationships, right? Zero to many, mandatory one or more, mandatory one-to-one, mandatory one. This is mandatory one-to-one, right? So, etc. So you can look through this, but Glyphy is a nice tool for this. There are more videos. This was just to get you introduced to entity relationship models and the issues of data modeling. More videos are available on Canvas. Talk to you soon.